Okay, hold on. Hello, hello. Good morning. Good morning. Good to see you. You will see me. Good to see you. Good morning. I'm going out of order. Good morning, Sydney. Good morning, DJ. Good morning, Pushpita. Good morning, Lena. I'm going out of order. I know I'm doing the chat next. Good morning, Ashley. Just trying to get rolling here. Good morning, Duran. Good morning, Tree. I'm looking at the chat. Oh, wait, there's more people here. Okay. Uh, why? Whoop. Good morning, Loani. Good morning, Sarah. Good morning, Munera. Good morning, Manpreet. More people coming. Hold on. And I know this is all craziness. Chat. Um, Good morning, Ashley. Good morning, Lena, with the exclamation point. Thank you. Good morning, Pushpita for the good morning, Sydney for the double. Good morning, DJ for the double. Good morning, Tree. More people coming. Good morning, Joran. I remember that now. That's great. Good morning. Good morning, Loani for the double, for the double. Good morning, Sarah, with the exclamation point. That's a double. That should be a portal. Punctuation marks and extra G's. Good morning, Monpreet. Thank you for Tuesday, Monpreet. We're going to hear about that in a minute or not. Good morning, Maya. Oh, cool. Thank you. And in fact, well, maybe if you could hang out for 2 seconds right after class, this is like no good deed goes unpunished. Um, so I could check in with you about that. That would be helpful, but if you can't, you can't. And when I say check in, I just mean like whether there's a recording or blah blah blah. But all right. And good morning. Okay. Good morning, Maya. Thank you. And for the dub, I see you both. And Eric and Fabricio. Oh, more people coming still. Okay. So I guess I'm not late. Okay. Okay. All right. Let's. Oh, no. Good. Thank you. I see things in the direct chat already. I hear you. No, even if no, I'm glad it happened to. Good morning, Fabricio, for the double thank you. And I think actually, I'm not trying to be rude, but I mean, oh well, he certainly should get a place over my board. Oh my God. Um, 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 no, and I want to get straight to trying to help you guys as best as I can in a minute right now. Oh, lots of people coming. If you didn't I'm not, the point of Tuesday of 2 days ago, the point was to, so that you could feel that you could work without having to worry about what I think or what you think of me or anything like that. Like it was to get me out of the way. So I'm not here I don't want to follow up and like I'm not here to evaluate how you did on Tuesday by any means. Uh, if you if anything happened at all, I think that's terrific. And if any of you got anything out of it, even by just listening, like all the terrific. But I'm anyway. But apparently it was helpful last year, and I hope it was helpful this year or last semester. But I'm not going to quiz you on what happened Tuesday. What I am going to do, um, good morning, Erica. I see that, and good morning, Fabricio. Okay, I'm going to switch the view in a second. What I would like to do today, the reason, one of the reasons the exam is not posted tonight for you guys. I mean, it could be if you want it to be, I guess. But the reason it doesn't get, I don't want to ruin your weekend or anything, but the reason it's posted tomorrow night is because you have lab today. That's a lot of physics in one day. I feel like you should have a chance to breathe or prepare more or talk more before it gets posted. So it gets posted tomorrow night in your case, and then yours is due Tuesday as opposed to the other sections where there's has to be due Monday, et cetera, et cetera. Now, so what I would like to do today is at least start, and I will switch the view in a second. I'd like to start by trying to answer any questions that you might have about the exam, whether that means about the practice exam or the homeworks that lead up to the exam or expectation, blah blah blah. I'd like questions whether they came out of Tuesday's sessions or not. Tuesday's session or not. I'd like to start by answering questions, and I'm almost nervous to say this, like we could do the whole period on Q&A, and I will be here today. I mean, I'm still sick, blah blah blah, but I'm not wearing a mask because like I'm by myself, whatever. I'm not going to make you sick through the Zoom. Um, I assume. Um, um, what I'm trying to say is I'm staying here all period. I would like to answer questions all period. Obviously, there's always things I can say if there's no questions. But my ideal, and I want to ask your help with this, I'd like to address as many needs as possible, which means spending a brief amount of time on each need. So that's going to somewhat require your help to ask that many more questions and to make the questions as concrete and specific as possible to keep me on track. And I will use the board to write out answers if that's helpful. But again, if I just spend the period like walking through one whole big problem, I don't think that's ultimately a good use of your time or as best a use of your time. So, okay, I'm looking at the chat. So I'm going to shut up and I will switch the view on the screen momentarily, like once we really get rolling. But we had, oh, okay. Okay, so good. So someone is saying in the chat that you had a lot of questions. That's great to know that you did stuff. You had a lot of questions. Great. We were lost on a couple of things. Fair enough. We wrote it down to ask you. Good. Now, when you say you believe it was in the recording, so this is the thing. The whole issue of the recording is a little bit dicey. As far as I know, I don't have the recording. And I don't want to get into all this right now. This is why maybe for 5 minutes afterwards I could talk to Munera or whatever, or later on. Like I don't believe I have the recording. And again, maybe you guys want to talk about this in private. I really hope that you also have a Discord server or like some private what do WhatsApp or something that doesn't include me, that you can discuss whether if you want to pass the recording to me so that I can post it in the normal way. I'm happy to do that. But if you don't want me to see it, I understand that also. It's like that's up to you. So, but I certainly haven't seen it yet, so I don't know what the questions are. So I kind of need you to tell me, like now. That's number one. And then, oh, someone else is here. Sorry, someone else is here. Um, and wait, yeah, well, basically that. Also, can you just well, no, I'll leave it at that. So yeah, um. So yeah, so it's up to you. Oh, okay, here we go. I did create a Discord. Awesome. That's awesome. I'm seeing in the private chat that there is a Discord just for STEM students. That's great. No, I think that's really important. Again, I mean, I think yeah, that's really, and it's important. It's important that I be really accessible to certain things for you, but it's also important that you have a space that doesn't involve me because it just gets into So that's great. And quick sidebar too, while I'm just looking at the chat, waiting for any kind of question at all. No pressure, but total pressure. Because I mean, again, believe me, there's things I could say. It's not that, and I will say, but I really think it's best if I try to address your questions, and it's best if I go in the order of like the shortest questions. Okay. Oh, great, Monpreet. First of all, you totally get points for that. Yes, you can. Sure, that'd be awesome. If your colleagues are into that, sure. Let me change the share settings so that you can. Oh no, I think yes. Here, I'm changing the share settings so you can just go for it. Yes, awesome. And that probably will be an opportunity in a minute for me to switch the view. But yeah, try to pull up the whiteboard we made. That'd be awesome. And if there's a bunch of questions on it, I will go in order of like a question that I can ask or answer the quickest to the longest. Okay. So Manpreet is going to try to pull up the whiteboard, I think. And while Manpreet is doing that, I'll even also say super quick, like this is dangerous, isn't it? Maybe I shouldn't. I'll just wait. Okay, I'll wait. Wait, you can't? Oh, but I thought I just changed. Could you try one more time? And if not, okay, well, I'll put down I thought I changed the setting on that. I did change the setting. Okay, try one. Well, all right, I'll unshare I'll stop my share. But Um, um, hang on. It should work, but okay, hold on. Okay, so I think my shares got, and also I'm gonna leave, wait, my, yeah, okay, so try now, por favor. Oh, maybe it doesn't work in an immersive view. Okay, I'll get rid of this view if that's it. Are you trying?
I am trying. I think the whiteboard didn't save on my account. I think it's probably because it's linked to your Zoom account.
Oh,
So maybe it's loaded as a meeting asset for you, but it's not seen in my meeting assets.
I totally understand what you, first of all, please give yourself points for, I mean, you just used your voice, which I really appreciate, honestly. So please, there's a portal for you to get points for the fact that you just use your voice. You should definitely do that. Oh, okay. And I think I even, and I understand what you're saying. I think you're right, and I think I do see it here. I deliberately tried not to look at any of my assets because I did note it, but here, okay, but thank you. Is this what we're, is this uh oh, it's not being presented. All right, I'm looking at it. You'll tell me in a second. Wait, is it, are you seeing it now? Wait, are you wait, now I don't hold on. Yeah, I see it, but you don't see it. I see that. Hold on. Hold on. Uh, I think it's trying. Okay, I think collect. Okay, let's see. Is this what you are looking? Is this what we're talking about? Or can you see?
Yep.
Oh,
Yeah, we can see it.
and
Yep,
this
that's
is
the one.
okay. So first of all, my compliments to everybody. Look, you may even want to remind me, on all of you, any of you might want to remind me that I should open a portal. Like this is where I didn't want to get weird. I don't want to like be a vet, but I want to give you guys credit for doing this Tuesday. Like this is awesome. Like any of you who participated, like should get credit. And you're and you're like on it now. That's cool. Okay. To bu- 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 bu. So that's awesome. Also, let me quick reminder. I'll get to this right now. This is really helpful. I also want to remind you, I know I've said this a million times, but I feel like it keeps getting lost or whatever. Or maybe raise your hand to acknowledge you just got another update, like class credit thus far. You all just got that right before class. It includes everything you've done, like everything that you've done has been graded and returned. And even though you can still get more points after the exam, on anything that you've done, like it's not perfect, even though you can still get more points, I want it to be clear. Whatever that number is that you just got from me 2 minutes before class, like hopefully, like maybe I think you are confirming that you saw it. Whatever that number is, literally, you take that number and you're going to add it to the grade that you get on this exam. Like and that is your projected grade so far in the class. Like, yes, you're also going to take a final. Yes, you're also going to have a lab grade. But I mean, the point is, whatever those points are that keep accumulating, they're real. You add them to your exam average to make your full average for the class. And, you can already see some of you have at least 6 points there that you're literally going to add. So just please, is that clear? Is that clear? I'm just saying, like, oh, it says as of February 12th. Oh my God, I meant March 12th. I'll change that. Yes, it's as of today. It's March 12th. It's as of today. It's as of all the work you've done as of today. Sorry. Oh my God. I'm so okay. Do you understand how to read? So that's what those points mean. They're not, that's already divided by 50, blah, 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 blah. Like that's your class credit. Could just someone confirm that you get what I'm saying? Okay, thank you, Sharon. Okay. All right, now to your whiteboard here. All right, I'm looking at it. Question box. Go over calculus rules. Imaginary numbers. Okay, that's fair. I understand. Okay. What is Q? What is R? What is K? Unit circle trig for this class specifically. Interesting. Okay, that's helpful. Um, and I'm going to change. Wait, sorry. I'm going to also in the thing. I'm right now going to change that where it says as of February 12th. That's confusing. I'm changing it right now so it says March 12th. So there's anybody who missed this discussion will understand later. Okay, sorry. All right. Good questions in the Zoom. Let me see if I can, as I say, answer them in the order of like easiest to. Okay, so I'm going to go out of order. You tell me if you're not understanding where I am or what. I'm going to answer the second question first because I think I can answer it the quickest. What is Q? What is capital Q? What is capital R? What is capital K in the context of that problem? They are constants. And that's a very good question. That's a very important question. They are constants. And does that equation do they ultimately mean something in physics? Yes. Does that equation like ultimately mean something in physics? Maybe even something we're actually going to learn later in the course? Yes. But the key point is that that doesn't matter. That you're going to get at least one big problem on this exam where you'll get some kind of equation like that, or very much like homework 3, where there's this business about weather and there's capital D that stands for degrees Celsius. And the idea is that you're literally supposed to at first look at the question, be like, wait, I don't know about these things. I don't know about the weather. He hasn't taught us about Q and K. What? But then you're literally supposed to have that reaction like, wait, this is about a bunch of stuff I don't know. That is true, but it's not meant to trick you. The point is that then you stand back, and as long as you know what is a constant and what is a variable, as long as you know what is a constant and what is a variable, and I'll tell you how to know that in one moment, then you stand back and say, if he's presenting me with a differential equation that I know the form of, specifically in the case of harmonic oscillation, like if he's literally saying second time derivative equals, excuse me, second time derivative of some variable. In fact, wait, I keep saying Q and K and everything are all variables. Wait, I got to look closer. In this case, yeah, no, they are all constants. Yeah, okay. If he is saying second time derivative of some variable equals -1 times some constant times that variable, then it is simple harmonic oscillation for that variable. Like that is like a huge, big, not obvious, but big takeaway for this material for this exam is that second time derivative of variable equals negative constant times that variable. That means simple harmonic oscillation for that variable. That means that variable can be expressed as initial value times cosine of omega times t. Right now, that's already a mouthful. Let me slow down for a second. But like and then you're supposed to do a bunch of math with that. Like and the whole idea, we're not trying to trick you, but no matter what, there's going to be at least one, if not two problems on the exam where we don't know the situation. We don't understand we've never seen the details of the situation before. But the one thing we're told about the situation is that that differential equation applies. And the whole learning that we're supposed to be sort of like doing and expressing is, oh, as long as that differential equation applies, then I do know all this stuff already about something I didn't think I knew anything about. Like that is the whole physics of this, is that we can describe brand new situations. We can make all these predictions of brand new situations as long if it turns out that that differential equation applies to the brand new situation. So the key is to know what are variables and what are constants. How do you know? On the left side, and maybe I should start using my board in a second, but I'm still like looking at your board. Stop me in the chat if you want me to if this is too much to handle without my board. But or maybe I can even draw on your I'm not sure. But um 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 on the left-hand side, if it says d2 bleh over dt squared, first of all, that's already a huge indication that this is what we're talking about. But whenever the bleh, okay, no problem, I got you. If it says d2 bleh, like whatever d2z over dt squared or d2 theta over dt squared, whatever is in the top of that second derivative, that's the dependent variable. Whatever's in the bottom should be t, that's the independent variable. So any other letter you see besides what's in the top of the derivative and what's in the bottom of the derivative, any other letter you see, even though it's a letter, you is a constant and you treat as a constant. You treat as though it's just a raw number. That's the first main thing. Wait, I'm gonna honestly ask. Okay, actually, there is one more thing I'm gonna say. Wait, is that at all helpful or at all clear? Like, can anybody give me any feedback? Like, does that address? So, is that a Sharon? Is that a yeah? It's funny because I see everybody like flying around on the board, which is cool. It shows you're paying attention. But wait, was that is that a yes that that's clear and I can go? I'm gonna take that as a
Yeah.
yes. Okay, thank you, Sharon.
So
Okay. Oh,
I
so,
also want to like elaborate.
okay,
Well, ask like a second question to that.
okay.
So when we say that Q, R, and K are constants, we don't need to use like the formula like K equals negative M over A in this case. It's we literally just treat it like a constant and we don't substitute anything into it.
Oh, wait, that's definitely true. Great question. You don't substitute anything into it. That is true. Yes. Also, let me add, every time I say that they are constants, every time I say that they are constants, I'm also assuming or believing or implying it. Maybe I should make this more clear that if they are constants, then any combination of them is also a constant. So, like, I should really wait. You know what I want to do? I want to zoom in on this. Hold on. I want to look at the document more carefully so I can see what you're looking at. Give me 1 second. Oh, I see it. Okay. Um, Wait, so you're looking at the second problem. Okay, yes. Okay. So in the problem that we're talking about, and thank you again for the feedback. Y is the dependent variable, T is the independent variable. So R and K and Q are constants. And yes, you don't have to substitute anything for them. You wouldn't know what to substitute for them. But I think this is part of what Monpreet is asking. I think it's Monpreet. Sorry, I'm looking at a different board right now. Like if they are each constants, not only does that mean that any combination of them is a constant, but also if you cube one of them, like that's intimidating. It's intimidating and it makes people feel like they should be doing stuff, but no, you're just cubing a constant. Like in other words, if r is a constant, r cubed is a constant, and r cubed over k cubed is a constant. Oh, and in fact, the problem even does say that they're constants, but that's okay. But so that's just to reinforce. Um, um, and wait. So wait, now I've lost. Does that answer your question, Mom? Sorry, I'm trying to do two things. Did that? I don't know if I just answered your question or not, or was that Sharon? I'm
You
sorry.
did.
Oh, I did.
Yeah, you did.
Okay. Um. I mean, and it really, the reason I'm excited again to all of you. I want you to know it's so hard to know. It's so hard to know, but like it's so hard to know what's the main subject and when am I off the subject or whatever. But like knowing the difference between a constant and a variable is honestly a big part of the lesson of all of this. It's not a side issue. And if you're just getting used to it now, if you're just starting to get used to the fact that, like, wait, just because something's a letter doesn't mean it's a variable, they good. Like, welcome to the class. It doesn't mean you're behind. It means you are learning the thing that's more subtle than it looks. Like, and so okay, so I'll leave it at that. But like, yeah, a big thing of what we're trying to like sort of learn in physics 204 is these general relations that really look very mathematical and that really they're all like y is a function of x. What's the derivative dy dx? But We're not just restricting ourselves to y and x anymore. Like what we're really trying to see now as physicists is whenever you used y and x in a math class, what y really meant was dependent variable. And what x really meant was independent variable. And those could be any letters at all. And then every other letter is just acting like a number. Like when you take the derivative of it, you of a function that has the other letters in it, the other letters just are treated like they're raw numbers. So you have to like reinvent that understanding for every new function. Not, I mean, you have to reapply that understanding for any. Okay, so that's the answer to hopefully to Manpreet's question. I'm gonna say what? Wait, is there any other follow up on that? Like anything I could say about, that could be helpful at all about that general problem that you did there? And I see the other questions. I will. We still have time, so I will get to the other questions. I think these are good. But even if that just made you think of something, does anybody else want to follow up anything about that? Okay, I'm gonna go a step further. And again, maybe this is. I worry about saying stuff that I don't write down. I know it like is harder for people, some people, but this reminds me, like that problem that we're looking at right now with um the Q and the R and the everything, like that's very reminiscent of like stuff from homework two, right? But then the first problem, which is fair game, then the first problem in the exam, in the practice exam, was much more reminiscent of homework three. Like I want to, so let me say something about, they're both ultimately about the same issue, which is this differential equation, simple harmonic oscillation, but they're sort of getting at it from a different angle. One thing I want to say is if you even see the similarity, if when you first look at this problem that Monpreet is asking about, that others of you have, when you first look at it, if you're like me, when you first look at it, you want to puke. I mean, I know that. Like, I don't mean to be gross, but like when you first look at it, you're like, what is this? That is a very common physics reaction. That is my reaction. What certainly was my reaction. Like, what is this? I don't even know. I mean, I even thought I was doing my work. I don't even know what this is, right? But then, if you have a little faith that it's not meant that somehow it does connect, you look for the underlying connection. Like you look for this has got to be similar to something. It looks out of nowhere, but it's got to be similar to something. Once you can even see that problem is similar to stuff in homework two, then of course you like take out homework two and start looking at it. Okay. And the other one, the first one in the exam, the one that's about electrical current, of course, I'm saying this sympathetically. Of course, your first reaction is, wait, we haven't even learned about electrical current yet. I don't understand electrical current. I get that. That's the point. What we're trying to say is right, but what you have learned about is this differential equation. And what you're trying to learn is that this differential equation applies to new situations, such as in homework three, where it asked you about weather, and we've never learned about weather, right? And now homework, so this, I'm trying to say that the first problem in the exam, at first, it looks completely out of nowhere. But if you can even get to the point where you're like, okay, this is the same kind of annoyance as homework three was, first of all, you've made great progress even to do that. And then you take out homework three and you look at what you did there or what my feedback was there. And let me tell you right now, I'm going to pause right now because now anybody who's done homework three has gotten it back. So I want to tell, so you, and I even put a very similar comment on almost all of it, at least the ones that came back today. I want to translate that comment to be explicit since you know there's going to be a problem on the exam that's going to look very much like homework three, right? The key of homework three was that, sorry. Oh, sorry. I just saw something in the chat. How long ago was that? Yeah, pause. Sorry, I know I'm all over. Someone saying in the chat, can you treat y sub naught as a constant? Oh my God, that is a great question. Sorry, I'm all over the place. I'm going to answer that and get back to what I was doing. Yes, the answer is yes. It's a great question, but let me firmly say yes. Whenever, and that is always confusing to physics students. If you're just getting that now, you are not behind, you are not alone, and you are not in trouble. You are making progress. It always confuses students that the variable, the dependent variable in this case is y, but y naught means the specific value of y at t equals 0. This will always be the case that you'll have the dependent variable, but then you'll have a value of that variable at t equals 0. That is the value of the variable at a specific time. So, yeah, this is a subtle point. That means that value will never change. The value of y is always changing, but the value that y had at t naught is always whatever it is. I forget, in this case, 200 or something. Like that is therefore a constant. That is a really good point. I'm going to say it one other way. Time is a variable, right? But my birthday is not a variable. The day on which it's not always my birthday. But my birthday is always that same day that I was like first born, right? Like not for, you know what it's like that, if that helps. So yes, you always treat, and that's why it's called the amplitude, and it has all these other properties. The initial value of the variable itself is a constant value. Yes, great question. You should give yourself points for that question. Okay, I'm going to go back to what I was saying before. But again, also, if I'm going to try to finish what I was saying a second ago, but you should really tell me in the chat if I'm taking it too long to say it, or if you can't follow it because I'm not writing it down or whatever. What I'm trying to say is this: on your homework 3, okay, the major insight that most of you ultimately did have, most of you got the major insight that you need to have to do that homework and to therefore do like the first problem on the exam or something. The major insight was that omega, the angular frequency, had to be the square root of the constant in the differential equation. In the case of homework 3, the constant was 121, right? If you recall, d2t over dt squared equaled negative 121 capital D. Again, I'm talking about homework 3 right now because I think it's like instructive for this exam. Most of you, one way or another, realize that in order to solve most of the questions, you needed to realize that omega, the angular frequency, was going to be the square root of 121. It was going to be 11. And most of you got that right, and that's great. What I'm here to tell you is your responsibility, but then a lot of you lost, you got good scores, and you don't need to go back and correct those scores. You got most of the points. I'm good, you're good. If you want to get a perfect score later after the exam, that's also fine. But I'm not worried about the points right now, and neither should you be. But I am here to give you advice for the exam. Where many of you lost points on that, like was in step 3. You might have gotten the middle score instead of the highest score on step 3. And you may be not totally clear as to why. The why is this. What we're trying to test on this exam is how do we even know? Why do we believe? Where did we come to the conclusion that omega, the angular frequency, is the square root of that constant in the differential equation? You might say, well, don't we call the constant omega squared? Good. Yes, we do frequently. We call it omega squared because we now know that it is the square of omega. But where did that come from? That's what we're trying to test here in the exam. Like that's the physics understanding we're trying to show. How do you show it? I'm telling you right now, and I'm going to ask you to raise your hand if you hear me. On the exam, at least the first time that you get a problem like that, where you need to where you go from the differential equation to some statement involving cosines and omegas, and you start using the omega as angular frequency, the first time you do this on the exam, you need to show that cosine is a way to solve that differential equation. All those exercises we kept doing in homework 2, where we kept asking, is this cosine thing a solution to that differential equation? You need to show that cosine omega t is a solution to the differential equation. How do you show it? You show it by setting up the expression, like writing down the expression as a conjecture, as a guess, as a theory, whatever, as a provisional assumption, whatever. Write it down as a suggestion. And then take 2 time derivatives of it and show explicitly that we use this cosine business because it works. How do we know it works? Because when we take 2 time derivatives of it in succession, like literally show 1, 2, we get back the original expression times a constant times -1. And that constant is indeed the square of the omega in the expression. Why? Because when we take two derivatives of it, we use the chain rule twice. So the omega comes out twice and like it gets squared. That's what you want to show me at least the first time on the exam that this comes up. And you want to explain, here's chain rule. Here's the derivative of cosine is negative sine. Like over explain that stuff at least the first time. If you didn't get 100% of the points on homework 3, that's why. And all I care about, the only reason I'm like telling you is for practice for the exam. On the exam, you show that the cosine thing works, and you show that omega is the square. Oh, good question. Okay, I'm going to shut up in a sec. I'm urging you. Consider this, whether it's a minimum requirement or a pro tip for those who are listening. Like you want to, you're doing something right. If you literally walk me through two derivatives somewhere early in the exam, you're going to have to walk me through two time derivatives and explain what's happening to show me that function you're using, when you differentiate it twice, it gets back itself times a constant times -1. That's the differential equation. I'm going to show up. I'm going to shut up and get to the chat. But wait, I'm going to get. Wait. Oh, great. And I also see something I mean, there's a hand and a chat. Wait, so I'm going to get those both. I'm glad you're with me. Yeah, okay. I still have more to. Okay, first of all, well, I see in the chat, would I want it on PAW or GDP? GDP, great question. Step 3, like most of what I mean, I mean, in step 3, you set up like here's something called the chain rule. Here's something called when you have cosine, the derivative is negative sine. Like you set up those, and you set up like we are looking in step 3. You're saying if this is a differential equation, what it means is we need to find an expression that when it's differentiated twice, it gets back itself. Like something, and then in step 4, PAW, you literally take the derivatives. So step 3, you set up what you need to take the derivatives and why. And step 4, you take the derivatives. Good question. Okay, Alice.
So I was gonna ask, like, um, do you prefer that, like, can we just write all of the formulas, like, let's say at the top of the test paper, and then just like if we number the pages, like basically be like see page 1 for formula, or would you rather have that we write each and every formula for like every question? So like if I'm doing like question 1, and then and I use chain rule, and then I get to question 5 and I use chain rule again. Like, would you rather I write the chain rule twice, or just write all the formulas at the top of the page, like on the first page, and then like just reference that page in every question when I use that formula?
Okay, I totally understand. Great question. Great question. I totally get it. And if you're actually asking my preference, I will tell you this. What it I don't prefer everything being I don't actually prefer all of them coming right at the beginning of the whole exam. Uh, I don't want you to be repetitive. You don't have to be repetitive. You don't have to keep presenting the chain rule every single time. You can do this thing of like see above, see above. You can do that, but the reason I don't prefer just a big block of all the equations right at the beginning, you can do that if and only if, then when you getting to their use, like when you get to the step 3 level of every single problem, if you literally said, see equation number 7 from page 1, that's fine. Like, and if that works better for you to be like that to avoid repetition, that's totally fine. But the thing I don't want, and so I'm not sure if this was your option or not, what I don't want is a block at the beginning of the whole exam. And then throughout the exam to keep saying, like, see page 1 block. Like, if I don't know which equation you're actually directing my attention to, then that's not comfortable for me because the fact is like some problems are going to use some principles and other problems are going to use other principles. So I really want to see one way or another. I'm not trying to waste your time. You can do it in the most efficient way, like that works most efficiently for you. But somehow it has to be clear when we start a new problem or like a new, part of a problem in I want step three acknowledged, like, okay, here comes step three. And somehow in step three saying, here's the ingredients that I'm laying out right now that are going to be needed specifically for this, like nothing extra, but nothing missing. So if that means that you're saying see equation A from the front page and equation D from the front page and equation E, like that's fine. Like that's fine. But I need to know that you are just literally giving me those ingredients and then last like this is a very good question. And again, and I almost now that I'm even saying this, like I think that was Alice. Yeah, Alice. Like if Alice ends up doing something like along the lines of like what we just discussed, which granted is like not exactly what I was saying 10 minutes ago, but that's all the more to her credit. Like if it's like kind of some kind of hybrid of like her style that really works for her, but is still covering my requirements, all the better. That's not like worse, that's like better because it shows it was really her taking the exam, right? So it's if she wants to come up with something like that, so she's not like writing the same thing a million times, totally cool. But let me also just like explicate to everybody if you do something like what Alice is saying, like again, like you have this like front page where you lay out the principles that you feel like you're going to use over and over again, and you give them numbers or letters so that I can refer back. Totally fine. But please then also make sure that wherever it is that you're laying out these principles, that you really lay them out. Like if, for example, if it's going to be chain rule, at least once, I want to see you show me that you actually get the chain rule, that it's not just like a memorized formula that like, got taken from the web or something like that. So it doesn't have to be more than once. And it can be before you do anything else, totally fine. But I guess I am saying to everybody now. I mean, so maybe Alice in the private chat could just let me know if I sort of just answered a question or not. And same thing with the other private chat person that asked about PAW or GDP. Just let me know if I did answer your question or not. But to everybody, like what I am saying is step three is really when all of you say you're not used to this or this is new to you, which I respect, right? What I secretly believe is the part like steps one and two may be new to you, but I think they're just annoying to you. I don't think they're hard. I think they're just irritating, and I respect that, but I'm asking you to do them anyway. But step three, I think, is really what's like new and different to a lot of people. Yes. Step three is where I'm really asking you to step back and really engage in the fundamental concepts and like strip them down and make it clear that you've really thought them through. The more you think them through your way and express it your way, the better we're both doing. So step three is where you want to focus. Whatever best way works for you, you want to go extra on step three. It doesn't mean you're proving things. Most of these step three ideas can't be proven like we prove things from them. You don't have to prove anything in step three, but you have to like establish the idea and like why the idea actually makes sense, that it's not just a memorizer. Quick, so I'm gonna go back to the class, to the topic, but this is all a long way of saying too, here's a pro tip. Okay. And I mean this in a encouraging, non-shaming way. But we've uh, we've gone through the cosine solution of the differential equation many, many times because it's hard, because it is new, because it's backwards thinking. It is not the way you're used to thinking, anybody, no matter what class you were in last semester. It's not the way you're used to thinking in math and science. It's reverse engineering. I'm serious. Solving differential equations for which you've never had a class before, you're just having to learn it on the fly now because that's the way physics is backwards thinking. So it takes some getting used to. Hence, I'm totally sympathetic to that. But we have done it many times. And I put class notes in for class notes for 2 days ago. You might notice we didn't have class notes 2 days ago. However, I did have a side help session with one of you that I think was helpful, where I reviewed like how we got to that cosine thing from homework 1A. I reviewed for that person and made a whole like 18 page or something note packet that just reviewed it, went through it again in maybe a more careful way. You might want to look at that, is what I'm saying. It might help you see again where we got this cosine thing from and how it relates to the differential equation. Where I'm going with this point is to be super honest and super honest. if I see on your paper like something like y equals a cosine omega t plus b sine omega t, okay, I know what that is. I know it's technically correct. I know what it means. Whatever. I know it's technically correct, but I also know we never said anything like that in this class. That's from the web, just to be honest, okay? It's not that it's wrong, but it's another way of thinking about this. And it requires another way of thinking about this. It's not wrong, but if you're going to say y equals a cosine omega t plus b sine omega t, then you really need to explain that. Like where that came from, what like why is it cosine plus sine? We've never said cosine plus sine. And you need to show how the sine then drops out and how we ended up with just cosine in this physics context. Like, so I'm saying be super careful about statements like that that just came from the web. You either need to really deconstruct them and show them how they make sense and relate to our class, or if you see something like that on the web and you don't totally get it, don't write it down. Use that as a indication that you should like look more carefully in our notes and see how we did it. I'm just saying, like, that's kind of a red flag. Similar red flag is with the Doppler effect. I know there's a formula for the Doppler effect that's all over the web. I'm not saying it's wrong, but it's very deceptive. It's very easy to misuse. It gets into a lot of issues that are problematic and it's out of nowhere. So if it's in your exam, I'm not saying it's wrong and I'm not saying you cheated on either of these things, but I'm saying it makes me look much more closely than you might want at like exactly what you're doing. It's safer for you to stick to how we've tried to explain these things in class. It's just safer. I'll leave it at that. So, okay. Oh, and I've answered the question. Okay. So, okay, it's 10:11. Um, but those are the pro tips. Don't use the Doppler formula from the web and don't use the A cosine omega t plus B sine omega t. Like we like, I'm just saying. Okay. So I'm looking at these questions again. Go over the calculus rules. Oh, the imaginary numbers. Which is oh, wait. Oh, I see. Can you treat why not as a okay, so that was one of the questions. That's great. Um, I'm looking at the time, which is going to be faster for me to answer. Unit circle trig. Um, I mean, I love the unit circle. Yes. Are you saying, can I hold on, let me see if I can do this quickly. Oh, no, I don't want that. Whatever happened to hold on. I don't know why that's not. Um, I'm getting too fancy. I'm not sure if I can do this. Oh, sorry. Okay, I'm probably getting too fast. If I okay, I'm getting too fancy. Okay. The unit circle. I'm just going to say this. I'm not. You may want to tell me exactly what you're asking about the unit circle, but here's what I think about the unit circle. I think the point is the unit circle has a radius of 1. I think it is very useful for this class, yes, but here's what's useful about it. It's a circle that has radius 1 necessarily, and who is at the origin of a coordinate system. Um, like whose center is at the origin of a coordinate system. I'm going to try one more time to see if I can do this. I don't know if yeah, okay. Yeah, okay. Does that work? No, I don't want to spend too much. So I'm just going to say this, but wait, are you even going to get? I don't even know if you'll get this whiteboard. I don't even know if this is useful, but you know what? All right, it's 10:15. I'm going to switch boards so I can do this right and so you can get the board. And I will not spend too much time on this, or you'll stop me if I start rabbit holing. But yes, a unit circle would be a good thing for you for sure to know. So hold on, we're switching. And I see the other question is the calculus rules. Oh, come on, come on. And I understand that many of you are comfortable with unit circles, so I'm going to try to say this in the way that's like the most, you know, helpful to the most number of people. So the whole idea of the unit circle is that it is a circle whose center is, can you see this? Yes, okay. Whose center is at the origin of an XY coordinate system. And whose radius is 1. And you look at any arbitrary angle made between a line, parallel to the positive x-axis and any arbitrary line. You look at that arbitrary angle between those two lines, and you see that that arbitrary angle, first and foremost, what you see is that that angle is just a section, a fraction of the entire circle, right? In fact, if if this arc length is called S, right? The angle by definition is the arc length measured in meters divided by the radius measured in meters, right? Which means the meters cancel out. And what that theta is just a fraction of like how much crust you get per how big the pizza is, right? That's what theta is. And in the limiting case, if you go around the entire circle, right, around an entire circle, you know the arc length around an entire circle is 2 pi times the radius, like by definition of pi of a circle, right? So if the angle is always arc length divided by radius, then then the angle around the whole thing is literally 2 pi, what we call 2 pi, from now on 2 pi radians. So what is 1 radian? What is 1 radian? 1 radian would be where the numerator of that fraction equals the denominator of that fraction. Like 1 radian is equal to, it means when S literally equals R, when that arc length is exactly the same size as the radius, that's what we mean by a radian. That's about 57 degrees, about a sixth of the whole circle. So a radian is just a section of a fraction of the circle. Technically, it's a 2 pith of the circle. What's 2 pi? Like three, what's 2 pi? Like 6.28. So a radian is like a little bit less than a sixth of the whole circle. That's all the radian is. That's one thing you can see right away from a unit circle. But the thing that, and I think that's helpful to, so from now on, again, what's this, all this business of radians and all of that? Oh, great. Whoever just put that in there. Sorry. It looks like the whiteboard is in the chat. That's awesome. Oh, oh, okay. I guess I did it by accident, but okay. A radian is a radian is a sixth of a circle, which means in physics, it's a sixth of a cycle. So on many of those equations, like F equals 2 pi divided by omega, or excuse me, omega equals 2 pi times F. Where do we get all those? The conversion factor is just that 2 pi, there's 2 pi radians per every cycle. Okay, anyway, that's one thing. But the other thing about the unit circle is that if you center the circle like this, then this coordinate right here is necessarily, now stop me if you don't understand this or if you already know this or whatever, this coordinate, I mean, this point right here is coordinates 1 comma 0. And this point right here is 0 comma 1. Like why? Because this point is over by an amount x of 1, because the radius of this circle is 1, and it's like right on the x-axis. So it's 1 comma 0. The one on the top is the reverse. It's right on the y-axis, but it's up a distance 1. How do I know distance 1? Because the radius of the circle, by definition, on purpose, is 1. So this is negative 1, 0. And this here is 0 comma negative 1. Now, who cares? We care because one way to understand cosine and sine from now on is cosine of an angle for all time. You can always picture the cosine of an angle to be the x coordinate of the point where the angle hits the circle. Like whatever angle you're looking at, that point on the circle, the x value of it is what we call cosine, and the y value of it is what we call sine for all time. In other words, right, when I say the cosine of 0 is 1, I'm picturing that I'm saying if the angle were 0, I'm talking about right here. This is an angle of 0 because we always measure from the x-axis, the positive x-axis. An angle of 0 means where does that arrow hit the unit circle? And if I'm asking the cosine, I'm asking what's the x coordinate of that? Well, the x coordinate is 1. What's the sine of it? What's the sine of 0? 0, because the y coordinate of it is 0, and etc. So the cosine of what you might call 90 degrees, or what I would call pi over 2 radians, the cosine of pi over 2 radians is 0, and the sine is 1. Like, I know those things because I'm picturing this. That is where the unit circle is useful. You can also get other values of cosine and sine from this, but I'm not sure that's as needed or necessary. Like, you're allowed to use your calculator for this exam. So I think this is the thing that's like the most useful. I'm going to pause in a second and look back at the other board and look at the chat and stuff. But I'll say this. I think this is super useful. Like, it's certainly useful for me to see the basic cosine and sine relations. Word to the wise or pro tip or whatever, cosine means x value on the unit circle. And that's how you probably first learned cosine. Yes, cosine corresponds to x on the unit circle, and sine corresponds to y on the unit circle. That doesn't mean that cosine and sine always refer to x and y in all situations, such as free body diagrams and pendulums and all of that. What they end up referring to in triangles is adjacent and opposite. Like, once you turn this into a right triangle, then cosine means adjacent over hypotenuse. It still is true here. Like, any right triangle that you make here has a hypotenuse of necessarily 1 and has and has an adjacent and a opposite. And like you could see right here, the cosine would be the adjacent over the hypotenuse, the adjacent is X, the hypotenuse is 1. So it like works out right here. But if you then if you start rotating triangles in free body diagrams, where if you rotate triangles, then cosine doesn't necessarily refer to X anymore. What it always refers to is adjacent. Bottom line, cosine is the X coordinate of any point on the unit circle. That's what you, so the unit circle helps you picture basic cosines and sines, especially like 0 degrees, 90 degrees, 180 degrees, 270 degrees, and hopefully helps you see why we don't call 90 degrees anymore. We call it pi over 2 because a full cycle is 2 pi. So a quarter cycle is pi over 2. In my mind, from now on, when I picture unit circles, I picture the cosines and sines, but I also picture the idea that what theta means is a fraction, a dimensionless fraction of a circle, i.e., in physics, of a cycle. That's my unit circle spiel. I don't know. Does that help? Can I get any? I mean, I'll switch back to the other thing, or we have 15 minutes still. Did that help anybody, or do you want to follow up anything about that? Oh, okay. Thank you. Oh, and thank you, Kayla, because I haven't. All right, great. Okay, good. Oh, that's a fair question. A private chat just asked, okay, so good, and you're clearly paying attention. Someone asked, and thank you for the thought, and you should all give yourself points. And again, remember, sidebar again, even these 5 point, you understand that class credit thus far thing is incorporating every single point you have ever gotten in any way. So these 5 points that you get, uh, every time you do the class, what do you call it? The game turn, like game turn 11, game turn 12. If you're worried about your grade in this class or you're worried about the physics, do those things. They help. Like, because I'm noticing that like a smaller and smaller percentage of people are doing the game turns. It is optional. You don't have to. I don't mind if you don't. You don't get zeros or anything, but like you might as well if you're nervous about your grade. And I'm not trying to sound nervous. I'm just psyched for you. Okay, so you should give yourself points for these affirmations that you're doing. But then someone just asked, are we ever going to use tangent or just focus on cosine and sine? That's a very fair question. Um, we actually do tangent yet opposite over adjacent. Tangent is a big deal. You may not for this exam. I guess is the fast answer. You wait, am I absolutely sure of that? Yeah, for this exam, tangent isn't really a big thing. It does matter because it's often how you go backwards from a y component and an x component of a vector in order to get the angle. Like you did that last semester in physics 203, or like I think you did, or you were supposed to. Um, like tangent is helpful in physics in a big way, but you're right. For this exam, I guess it doesn't come up that much. Um, So I'll just leave it at that. Yeah, yeah. But I mean, it is a thing. Like, don't totally forget about it or put it away. You will need it later in the semester. But yeah, not for this exam. Good question. Um, so we have 12 minutes left. I will answer. I think it's best if I answer the other question now from the from your notes. Um, oh yeah, basic derivative rules and the I business. Well, the basic derivative rules that I think you should know and be able to present in some kind of clear way, like not prove, but like show that you understand them. This is one thing you should know, right? And like, and and how do you explain? You don't have to prove that. You actually can prove it, but you don't have to prove that. But just give a quick example of it. that makes sense to you. And the basic example that would make the most sense is just do a straight line example. Like if y equals mx plus b, if y equals mx to the 1, you know, plus b, the derivative of that is m, right? Like plus 0. Like the derivative of a straight line is the slope of that line because derivative means slope. I'll leave it at that. But you like, and so the derivative of a constant of a horizontal line is 0. Like that's what this is saying. And then just blowing it up to like larger and larger exponents. But this is just a way of saying when you're taking derivative, you're getting slope. So think that through and understand it in your way. Maybe make a picture or whatever. But that's one rule that you certainly have to use it, right? I mean, um, but then another rule is if y equals cosine of x, then dy dx equals negative sine of x, right? And similarly, sine of x, both of these, you need to know that. Now, again, am I expecting you to prove that? No, but you can really show that again with slopes. The real thing okay, pro tip, I guess. If somehow you can get across to me once and you don't do this every time in the exam, this is back to Alice's thing. I'm not expecting you to re-explain this every single time, but at the beginning, like front load your exam, front load the exam. The big pro tip is anything you really actually do think you understand so much that you think is obvious and doesn't warrant explanation. If you think it's obvious and doesn't require explanation, that probably means you really get it, which means you should over explain it. You'll get tons of points and you'll set me up for wanting to read the rest of your exam with total pleasure and maybe more like informality. So anything you really do get and you think doesn't require explanation, probably over explain it. Anything you're tenuous about, anything you don't really get, probably requires breaking down into smaller and smaller steps and explaining those, or even admitting where you get to the point where you don't understand. But admitting that you don't understand this tiny step, breaking it down into tiny steps and admitting you don't get this tiny step is a heck of a lot better and will get you a lot more points than just leaving big clouds of like unexplained things. So anyway, what I'm saying is with derivatives at the beginning of the exam, what you really want to show me is that you get that basically at its root, what a derivative is a slope. Everything comes back to that idea of all this derivative stuff. So you could show with cosine and sine, like give a little cosine graph and show how you walk along the cosine graph looking at the slopes of it and making a new graph out of those slopes. The new graph out of those slopes is a sine graph, but upside down. Yeah, and you'll see that if you do it, that it's upside down, it has a negative sign, and vice versa. You can literally show that. You don't have to be, you don't have to understand calculus to the perfect level to show that. But so the power rule, the trig rule, or the trig rules, and then the third that you do need to know, well, the third is chain rule. Oh, I'll be consistent. Which again, I would recommend writing something like this. Think about this until it makes sense to you, and then you'll be able, sorry. Yeah. These are my words. You could put it in your words. But again, I would recommend, again, I'm looking at the time, 6 minutes. Okay. With chain rule, another red flag or pro tip, if you just express the chain rule with prime notation rather than like dz, like dy dx, like it could be correct, but I'm going to scrutinize it more because it's not the way we talk about it in physics. Like that's just advice. Like I'm not saying you're cheating. I won't accuse you of cheating, and I won't say it's wrong if it's wrong, but I will look for like that much more explanation if it's all in prime notation, because I think a lot of physics meaning gets obscured when it's in prime. So my recommendation is to try to think of it this way, and you'll know you get what I'm doing if you can. This is now circling back to like the beginning of this discussion. If you can make up your own letters and still see the pattern, like it's not that you have to say Y and X and Z. You can make up totally other letters like W and Q and R. But if you can make up your own letters and still see the pattern and see how it works and see how it makes sense even with your letters, then you know you've done something and you know you're showing me that you've personalized it. Like literally, like that is a piece of advice right there. If you literally wrote this in your exam, but you did it with W and Q and R or something, and made it clear that you're making up new letters and you're letting it be this and that, and it worked, I would know you know something because do you see what I'm saying? So that's just like one easy thing to do to show. Okay, anyway, so that's the chain rule. And then now I'm going to circle to your thing that you're asking. We have 5 more minutes. Another rule that we didn't talk about a lot, but I know you've done in math classes a lot, is if y equals e to the x, then dy dx equals e to the x, right? Now that even means, just like with the cosine and sine, you can put that together with chain rule. Like if that means, so I'm bringing this back now to we have 4 minutes. Let's go straight to this thing, right? That was in the homework. Okay, here we go to answer the final question of your thing. Um, then if you know that if y equals e to the blah, the derivative is e to the blah, and we know chain rule, that mean, and if we've defined some constant, so if we're defining, now this is a real math thing, but again, you didn't need to know this in advance. I'm just telling you now. If I is a constant number, and that number happens to be the square root of -1. That's, I mean, it's called an imaginary number in math, but so what? Like, if it's a constant and the constant is negative square root of -1, then to cut to the chase, according to the chain, if I put that together with the chain rule, I'm not going to do all the steps right now because I know you've only got 3 minutes. But the derivative then the dy dt, maybe I called it dx dt in the homework. That should not bother you at this point, or you don't want it to bother you soon. The derivative would be, okay, e to the whole inside, I mean, right? E to the blah times the derivative of what's in the inside. Now, what's the derivative of what's in the inside? Well, the variable is t. Everything else is a constant, even if they're intimidating, even if one is a Greek letter and one is a letter you've never heard of before. They're constants. You're told they're constants. So the derivative of a constant times a variable is simply the constant, right? So the constant would come out. That would be the first derivative of that. Like, in other words, I'm just treating I is just a number. 2 more minutes. But then if I do another derivative of it, I'm going to do the same thing again, chain rule again. So the I omega is going to come down again. So I'm going to get I omega squared e to the I omega t, right? Kind of like how omega got squared in our cosine thing, right? But now here's the thing. That means I squared times omega squared e to the I omega t. And the one thing that you were told is that I itself is the square root of -1. Even if I don't like care or have any context for that, if I is the square root of -1, that means that I squared is -1, right? I is the square root of -1. Therefore, I squared definitely equals -1. So this whole thing becomes -1 omega squared e to the I omega t, which is interesting because that means that d2y, I called it y this time, it's okay, me equals negative omega squared times the original variable. That means apparently, it just means if you're asked in the exam, does this weird function that we just made up, does this weird function, does this satisfy the differential equation for simple harmonic motion? Evidently, yes, it does. Because when you, as long as you define I that way, which we just defined it that way, if you square it, I mean, if you take two derivatives of it, you get back itself times omega squared times -1. So yes, it's a solution. That's and that's just based on the definition of I that was just introduced. So that's another example of just like of just accepting constants as constants. If you did I to the third power, you'd get negative I by the same reason. If you did I to the fourth, you get -1 times -1. That's one. And so and then I to the so I cycles in fours just like cosine does, it turns out, if you just apply the definition. So that's why it's convenient to use for that. But you didn't have to know any of that. You just have to take the constant on its own face and follow the rules. All right, I hope that was useful. I think I answered all the questions that you put on the sheet. I hope I did. Um, Good luck to everybody. I can be reached. I mean, I'm whatever. I can be reached, but here. I can't be reached once the exam is, but I'm reminding you, if you try, I mean, I am obviously a little whatever. I'm rooting for you. I think you'll do well. I want you to do well. I think you'll do well. Rock and roll. And I'm closing the recording. I'll stay here for a second if anybody has questions or anything, but I'm stopping the recording and you can go to class and have a great lab today. Have a great day. Thank you. Okay, I'm stopping the recording.